Mixing a song completely, to its perfection is one thing, but once you're working on something like this, on a pattern, on a beginning idea, when sketching something and composing, it's also really important that you have that rough mix done at least, because if you don't really have the feeling of what the track is supposed to be like, if it's missing something, not missing something. And you could have seen me as I add any of these elements. The moment I hear when I add a new element that it's too loud, I just volume it down. So every time I reopen the project to work more on it, if I hear something too loud or something too quiet, I try to remedy that. So I always play with the level. And it's important to understand that, you will do the mix when you get to the mixing stage. So now you have the idea, then you will create an arrangement and some structure to it. But in the end, you will, get down to mixing the track to finalize it. Before that, I think it's really important that you get your track in the ballpark, in that, ballpark where it sounds like the idea you actually had in your mind. So in your arrangement view, you have all of these indicators right there. They are quite small. Once the channels are closed like that, we can open them all by clicking Alt and then clicking on any of these arrows so they all expand. So you can see the indicators for the volume of each one. And we already talked about it. We also have that in the mixer, which, by default is like that. But if we expand it, we do have more controls and we can see more of the details concerning the level. Now, we already talked about this in the beginning course of Digital Audio Workstation. But right now, I think it's a good thing to go over it again. So once you play the song, take a look at all of these, meters. You see, they all have this, see-through green that's a little bit darker, and this solid green that fills it up to a certain point. Now, this see-through green, this higher green level that actually has these peak values holding, that's our, nominal level, the level at which the audio is working at. So we can see all the transients, the maximum peak value of each one of the samples in that digital audio. But, the solid green one is the RMS. It's our average level. So it gives us the average value of the level in time. That gives us a little bit better understanding of, how loud that signal actually is. Now, there is a big difference between a signal being loud for a really short time and being loud for a really long time. For us, physically, for human ears, something that's louder for a long time, it actually seems louder than something being louder than that even, but for a short while. So having really short peaks that really peak through really high in level, it doesn't really sound that loud as, let's say, a constant signal like, let's say, a sine wave or a square wave playing at a certain level. So that would be, I think, a good comparison if we had a sine wave and a square wave in the same level. Let me just close all of these out. So I'm going to load in a serum, and in serum I'm going to play all these basic ones, basic shapes. I will play a sine wave and then I will change to the square. So let's do that. Sine and a square, and let's check out the levels for that. So let me play a sine wave first, somewhere, let's say here in the empty space, just like that. I'm going to write a note for that, like this. Let's say something not as high, like C3, like this. Okay. Now I think I can freeze that one. So I will freeze the track. I froze it, and now I will pull out a new audio track just like this and pull that down by holding Control. So I have that sine wave right there. Now what I'm going to do, I'm going to unfreeze this serum, get into it, and change this into a square wave. Okay. Now this square wave, I'm going to freeze that again so that I have that square wave playing. And I will create a new audio track. Well, not even new. I will just pull that right here. So let's see what happened. There is a difference between these two. A difference in level. Now, as I did not want that, you see, it does not seem that there is actual difference. If you see the maximum of this sine wave and the maximum of this square wave, they don't seem to have any differences. Yeah, they do in this small portion. Okay, so if you look at the flat part of the square and the flat part, you see the highest part of our sine wave, they are the same. I will even do us a favor and just, because this square wave actually imitates, an analog square wave. It's not like a perfect square. It does have some oscillation, you see there, just in front at the beginning every time it changes the, position. So I can even pull that one down, but that wouldn't really do it justice. So we do have, a sine wave and a square wave rendered out at same levels. I didn't touch the levels in serum, and I will delete that serum now. I don't need that. But I will play the sine wave and then the square wave for you to hear the difference in apparent, in the subjective loudness between those two. And those two are at the same level. So remember, they are at the same level. This is just a small difference with this small peak. But this flat part is as high as the sine wave goes. So we'll play it, so try to see the difference between those. And we will also check that out on the actual, meter for the channel, for the track. Let me remove these returns. So right there. Let's check it out. Yep, those two. So let's play that from the beginning. So check out the actual average level difference between those two, the solid green. So it is higher. The actual level of the square is higher than the sine wave. Now I could get that, in any different number of ways. So let's say I take this sine wave just for better measure, and I will take a saturator, just like that. Put it on the track, and I will try to saturate. So I will make the saturator go over to 0 right there. Let me try that. More. So that's plus 30. Let's say that's 30 exactly. And right here, I'll go minus 30. Okay. So let me freeze that. Pull that out to a new audio track, just like this. Too much. I did too much of the actual output. Let me leave the level where it actually was. Something like that. Okay, freeze that. Unfreeze this. And take out the saturator. So let me get these two to the same level. Now we have a square wave, almost a square wave. There is a little bit of, slight, you see, curve down there, but almost a square wave. So I'm going to take that one and volume that up until I see it's the same level as the sine wave. Okay, there it is. So now it's the same level as the sine wave, but it's a different, you see, different shape. So maybe even a tad bit more, like that. Yep, same level. So let's see, can we hear the difference between those two? So you see, even the average that shows us the actual level, the average level of that signal shows us that this one is louder. So to a human ear, it will be louder because, after adding those values of samples, the amplitude in time and dividing by the number of samples we took, we get an average value. For the sine wave, it's going to be lower because right here we have many more samples in like higher values that we are going to add up and divide. So the average loudness of a square wave is louder than the average of a sine. Now, that same logic can be applied to drums, the punchy drums, they don't sound that loud. Any kind of sound that has those transients, that has a lot of transient energy, like this one, does really not. You see, it's all flat in the beginning. Let's find something that is like this clap. You see this little peak right here, right there, that goes really loud. That's not going to make our clap sound any louder. But if I push it hard enough, upwards, it will clip our master track, but it won't make it sound as loud. So let's say it like this: flat sounds sound louder than the ones that have, just this tiny bit, of signal that passes that level. And when we look at that level right here, you can see it reaches high up, but its actual average value is really low because everything else in that signal of that clap really is low, just like that. The discrepancies happen between the peak value, our nominal working value, and the average value, the actual subjective, loudness of the signal, depending on how long it actually stays loud. How long it's loud, how long it's quiet, all of that makes up for the loudness of a certain sound. So once you're mixing, take that into account. Don't just blindly look at the peak values. Just take a look at the actual average, at the actual subjective, loudness of a sound when mixing, if you're using meters. And I should suggest you should. It's like the most important thing is how a track sounds. So we are going for the sound. This is what we are creating. But, visuals can really help you in deciding and seeing why something is the way it is, why it sounds the way it sounds, because you have all these visuals to help you decide those things, to analyze things and understand them better. But to get back on the subject of actual, loudness and gain structure in a song, what you should be doing when you're doing, a pattern like this, starting an idea, is you are mixing your song roughly at the very beginning. So I would not leave a bass sound in this track going really loud. Let's say this is the bass, going really loud like this. So I would try to eliminate that discrepancy where the bass is too loud at the very start, because, having it mixed roughly, just like this, you see, I don't even care if it's -8, -7, somewhere in the ballpark where, when I play it, it sounds close, to the final sound that I actually want. Of course, we will spend much more time on that when we get to mixing and making definite decisions, like really precise decisions of 0.03, 0.3 of a decibel. For now, it's just getting it into the ballpark. So mixing your track as you go along, making the idea will help you make it sound better, give you more, influx of emotions, make it sound more energetic, so it gives you more inspiration, to continue working on the track. This is why we deal with it immediately, because we couldn't hear any of the other elements. If any of these hi-hats was really, let's say, really, really loud, we wouldn't hear any of the high frequencies from, let's say, synthesizers or anything else that has them. So this is why this gain staging, this is why this mixing from the beginning of the idea is actually important. And it really helps you in creation, during the creation of an idea.